I'm Carrie. I'm with Docker. This is Stephen Follis. He is going to take you through Docker tools for modernizing legacy applications. We should have about 5 minutes at the end for questions. And then if there are more, Stephen would be happy to answer them for you outside the room. Thank you.
Absolutely. Thank you, Carrie. Hi, everyone. Good afternoon. Hope you were having a wonderful time at DockerCon this year. I know I certainly am. Just kind of being fueled off of coffee at this point based on a couple of long days, but great to be with you all today to talk a little bit about the different kinds of tooling, techniques, and approaches we have related to modernizing legacy applications. So if you've been around Docker at all for the past couple of years, you know we've talked quite a bit around this MTA idea, this notion that we're going to use container technology not for DevOps or greenfield microservices, but that we can take the same tech and then use it for those brownfield apps, those legacy apps. Apps that I may have some source code for them and I'm still developing them, or they may be legacy apps that are just running, but I still want to be able to use container technology to get business value out of that. So this is a motion that we started, over 2 years ago at DockerCon Austin back in the day. And over the past several years, I've been working with customers of all shapes, sizes, industries around this motion. So today what we want to talk about is some of the different tooling that Docker has invested in to make this process easier, and then also some of the other techniques and strategies and kind of what we go through when we're working with customers around addressing brownfield and legacy applications. So a little bit about me, Stephen Follis, as was already mentioned. I'm a solutions engineer with Docker, so I work with our customers predominantly from a pre-sales perspective as we're first kind of talking about what containers can mean for their organization. We talk about architecture, we talk about all sorts of good things. So my background comes very much from the .NET world, and the Microsoft, Azure, MS SQL Server, more that side of the tech world. And so today's a lot of the demonstrations and kind of examples are going to have more of a Windows flair to them, but this is by no means just a Windows session. Everything we talk about today is perfectly applicable for both Linux and Java-based apps or for Windows and .NET-based applications. So just to set a bit of context here of why we're talking about this whole MTA motion. I often get questions around, why would I do this? Why would I mess with this? These are old apps. They're 5, 10, 15 years old. What's the value around it? And so we are seeing customers get substantial value out of doing this MTA motion and using containers for those applications. The first piece that we really help with is around budget. The consultants out there say that on average, roughly 80% of an IT budget is really spent on existing initiatives. And so that means there's not a lot of wiggle room, just about 20% to go out and try kind of new initiatives, new projects, new applications. And so it can be awfully hard. Oftentimes organizations can want to go look at blockchain or social or more greenfield or cloud native applications, but oftentimes there's just not a lot of budget for it. And so what we can do with containers is drive that 80% number down. One of the benefits around containers is density. So I can run the exact same number of applications in containers with far less infrastructure, driving that cost down, freeing up dollars in the budget to go do other types of initiatives. Second is all around application changes. So what we find oftentimes is that especially for legacy apps, a lot of these are running in a basement in some server somewhere. We may or may not have the source code for those apps. And so we're very scared about those apps going down. And so what do? We don't touch them. We don't change anything. We don't tweak them. The little copyright on the bottom of the page says copyright 2011 because it's the last time we edited anything about the app. And so we're very reticent to do any kind of tweaks to those applications. However, when we move those apps into a container, we can have the confidence to make those changes, to make those updates, to be able to tweak and adjust those apps. And that's because while we typically talk about containers as a great way to roll out new updates, one of my favorite parts is that rollback process. So how can I roll back to a last known good state? If we do mess up the app somehow, I want to be able to get back to how it was working. That rollback notion really helps us from a container perspective. And then finally, keeping the lights on. We increase agility of organizations. This same technology is able to allow others to go out and experiment with new technology stacks very easily, to go adopt trends that are out there in the industry, and we make it much easier to do than back when you had to go procure large servers and licensing and all the other complexities there. We make that process easier. So these are some generic reasons why we see folks interested in MTA. Kind of in my world and working with a lot of our customers that come from more of that Windows background is also the fact that in about 6 months, Windows Server 2008 is end of life. And so we've talked again about this quite a bit over the past year, but as a bit of a reminder, everyone I talk to has some number of Windows Server 2008 sometimes Server 2003, sometimes Server 2000, that are still in the organization. And so containers can give us some benefits here. And talking with our customers, they're looking at it going, well, I can just lift and shift into a VM, get onto a newer virtual machine. That doesn't give them a whole lot of other benefits there. They're still in a VM-based application. By moving to containers, we not only jettison the legacy Server 08, Server 03 OS, we also can move towards better standardization for my apps. So I move into this world where I'm going to build, share, and run those applications the exact same, whether they are a 15-year-old application that I built over a decade ago, or if it's a 15-day-old application that's a greenfield app. I get consistency on how I build and deliver those apps. So just a little bit of groundwork as to why we're kind of talking about this motion around MTA and that it's solving problems, and now we're after how can we help accelerate and make that process easier for you and for your applications. So today we're going to talk a little bit procedurally about how we look at these kinds of engagements and these kinds of processes. So I'm going to start talking a little bit about application discovery. So how do we go out and assess and discover applications that are running in data centers today? Next, we'll talk about how we actually containerize those apps and what kind of tooling we have that can help expedite and simplify that process to move from a virtual machine into a container. Once we have that application containerized, we need somewhere to run it. We don't typically run on individual dev laptops. We typically run on a cluster of machines for high availability, for DR. So then we'll talk about how we can deploy and run those applications on top of clusters and how we can manage multiple environments with those servers. Finally, we'll talk a little bit about what I'm calling evolving applications. So once I've got an app in a container, what are some quick wins that I can do around that application to add additional features and capabilities that are kind of commonplace today, but may not have been commonplace back when that app was originally created. So we'll walk through all these pieces today, and we'll leave some time at the end for some questions. So app discovery. App discovery is all around being able to answer questions about your environment. So what percentage of my portfolio can be containerized? What are those apps that work well? What are the ones that don't? So we know, right off the bat, any kind of fat client type application is not going to be containerizable. So those that are running on the desktop, things like Windows Forms, Silverlight, kind of those modern apps that we've got in Win 10, anything that has a big fat desktop client, kind of outside the scope of containers, in that we focus on the server-side components. So oftentimes, if it's a client-server relationship, we can usually containerize the server-side stuff. But if it's desktop applications, those are ones that are immediately we can think, well, they're kind of out of scope. We can't really do anything for containers there. We also get questions a lot around COTS-based applications, so off-the-shelf, third-party applications. That's oftentimes being kind of understanding how many of those apps are in the environment, if those vendors are still around, if the licensing is taken care of. COTS apps are ones that can be a little bit prickly when it comes to containerization. Oftentimes, the question is not always about can it run in a container. It's more around, especially with enterprise software, if running in a container is a supported configuration. Are we breaking any kind of licensing issues by putting this app inside of a container? Do we have all of the installation artifacts that we need to get that installed? So COTS can be a little bit tricky based on kind of the complexity of the app. And there's also the fact that because since you didn't create that application, if you get stuck, sometimes it can be hard from a subject matter expertise to know how the app installs and if you're stuck what all the other dependencies are for that app. So percentages of the portfolio, what can be containerized, what can't, is something very important to get right off the bat. Where do I start? Most folks come in and say, I've got the most difficult, gnarliest application in my entire portfolio. We want to start with that. And the downside to that is that it can kind of set yourself up for failure a little bit. We typically like to recommend, hey, let's start with applications that are representative of the portfolio, so not a hello world, but let's also not try to go bite off SAP or PeopleSoft or something super complex for your first app. Oftentimes organizations are new on this container journey. They're building muscle around containers, how to build Docker files, how to build Docker Compose files. Choosing easier applications first makes that a little bit easier and set yourself up for success as you start getting into more of the portfolio. Also, when we're looking at an environment, just discovering which apps, if there's any commonality or patterns there, where we can group certain apps together and work on them as a set. And then finally, just understanding what's in the environment, what kind of operating systems are there, what versions of different frameworks are there, which web servers. Oftentimes, we can have a good understanding of our servers, but not necessarily the apps that are running inside. So discovery is all about being able to answer these and get a good feeling for what you have in the environment, and therefore how that can fit into a containerization strategy. One of the charts that a colleague of mine, Lee, put together a few months ago that I really like is around level of effort for migration. So I always hear, hey, Steve, can we containerize X? Will Y work in a container? Can we do things with Z? And so more times than not, the question is not kind of yes or no, it's more around level of effort. We rarely run across applications that just cannot be containerized. Typically, it's more of a, yes, it can, but it's going to take a lot of hours. And so kind of being able to judge if it is if there's ROI on that activity for a given application would matter there. But where we usually like to start is up in this top left quadrant where it says easy. And so these applications in that bucket are ones that are typically stateless, so we're not having to worry about persistent data and where do we store data, what's the performance of that data, all the storage considerations there. There are also applications that typically are standalone. They're not it's not required that they kind of coexist with other instances in a cluster type environment, so there's less interdependency amongst containers. As we move to the left and down, we start getting more sophisticated, right? So we start adding statefulness to the applications. We have apps that have data that need to go somewhere. As we get down to the bottom left, these are also apps that are clustered together, typically data type applications, different databases, queues, different kinds of workloads that we want to make sure we can persist data. They become a little bit harder. And so that's where if we can get an idea of which applications we're working on, and if this is kind of a low, medium, high level of effort, it can help us build a project plan, can help us scope out timing and resourcing and what the level of effort is going to be as a whole for these kinds of initiatives. Another way that we like to look at this is what we call our archetype model. And so we've put together essentially kind of buckets of applications based on different characteristics for those apps. So if we start on the left, these are our least complicated applications. These are our .NET or Java web-based applications, 2, 3 tiers applications, more of our bread and butter for containerization. In that they're well understood. There's lots of samples out there, lots of examples of how to do this kind of containerization. And so we start from that point. Typically, user authentication and storage are two top-of-mind things to worry about. So you'll see we've got 2-tier web app and then 2-tier web app with auth, for example. So if we need to go integrate with a particular identity provider or something like Active Directory, that ups the ante a little bit from a complexity perspective. So we have these buckets, and we typically will go out and as we're assessing and discovering applications, start kind of placing them in buckets and then being able to kind of better understand what we have in the environment. Because as we get further to the right, you see we get into these web service applications, more complex web services, things that are more SOAP-based, and then on into web apps that have things like background processes. And so web apps is where we like to start, simply in that they are the best well-known, typically easier to install. We've got some mature tooling that we'll talk about here in a moment. But as we get towards other types of applications, it's simply more of a matter of level of effort more than anything else there. So when it comes to actually doing the actual discovery process, we've seen several different options that have worked to varying degrees here. So the easiest one is manual. Somebody fires up a spreadsheet, you start opening up remote desktop sessions and SSH sessions, and just start spelunking around your data center. It's not the most efficient, but hey, it gets the job done. It can give you, especially for more kind of pilot engagements or when you're starting small with a particular team or two, this is a fine way to go in and be discovering details about those workloads, about those applications. We also have those that choose to utilize config management databases, or CMDBs. These are typically databases that list everything about your environment. So they have information around servers, around where they're located, different networking characteristics, and can provide quite a bit of information. That said, CMDBs are typically more focused on servers than apps, and so ensuring you can get that granularity about what are the actual applications running in that environment, what are some of the details there that we would be interested in when it comes to containerization. And then finally, there's a whole category, a whole industry out there around automated tooling that can go ahead and do a lot of this process for us. So the Movairs of the world, BMC Discover, Risk Networks, a wide number of folks that have some excellent software that can scan an environment for a duration of time and then generate reports. Where I really like these automated toolings is that they start doing a really good job of interdependencies. So often they're looking at network traffic, and they can do a good job of saying, application server A is talking to this file share, these 2 databases, and these 3 servers over here. And so you get a mapping and a linkage of your servers and where those applications are working on within the environment. So these are all just kind of different ways that we see the last kind of bucket is around systems integrators. Often have very mature practices that can come in and provide human resources, that can provide tooling and methodologies, and do paid engagements around this process. is also an area to get really the best, most detailed information is kind of going that direction as well. So we have a lot of different ways that we can discover the environment. It really kind of comes down to how many apps you've got and kind of the resources you have available for doing some of this assessment. So. Good. So as far as containerizing the apps go, once we have a good understanding of our environment, number of servers, number of apps, different characteristics, it comes time to actually start doing the actual containerization, right? So just by moving a legacy app into a container, we're getting some benefits here. So we're seeing benefits around security. It's running in a more isolated envelope than having a full operating system. We can move it onto a supported operating system so that we have security patches and updates there. We get portability, so as soon as we containerize this app, it can go across my laptop to an on-prem data center, to the cloud, to hybrid, to multi-cloud, and we get a lot of portability benefits there. Updating the app becomes easier, having consistency with the other apps in my environment, and also cost savings around density. So all of these are, simply by placing a container, we get benefits here around this application and make it easier to run. And so the options here is that to containerize an app, we need that application and we need a Dockerfile. And so we can certainly sit down and start up with a blank screen and start hammering through with a Dockerfile. Or we can use a tool that Docker's been working on over the past year. I think we showed it a little bit in the keynote yesterday, something that we call our Docker Application Converter, or the DAC tool for short. So DAC is an automated tool that's really focused on automating this process of containerization. So it's going to, we point DAC at a particular server, a particular box, and it's going to go out and look through that environment. So it's going to first look at the operating system level, whatever it can determine about that OS. What are some characteristics of that operating system? It's going to look at the application servers, so things like IIS, WebSphere, WebLogic, to determine information that it can find. And then to look at that actual application. And so there's a system of pluggable detectors that today support those ones that I just mentioned, Windows, Linux, WebLogic, WebSphere, IIS based applications. And we're looking at how we can expand that to more kind of specific pieces there. So once DAC goes out and discovers all it can about an application, the output there is a Dockerfile. And so the Dockerfile is the piece there that's going to take all the information it has and pre-generate that for you. So the DAC tool is not a silver bullet for every single application that mankind has ever created. Applications are beautiful snowflakes and are all truly unique. But what DAC does allow us to do is for apps that fit right inside of its wheelhouse. These web applications, 2 or 3 tier web apps across that kind of fit in, that have a detector there. We can help expedite the process by pre-generating these Docker files for us and letting you focus your time on the more challenging applications within the portfolio. And so there is no complete kind of silver bullet to just automatically press a button and have all of your apps containerized, but DAC is moving us forward and being able to automate some of the more repetitive type applications to make it easier on you and be able to move a little faster there. So to give a little example of what this DAC tool looks like, I'm going to switch over to a virtual machine. Hope that's good to see. This is Windows Server 2008. Again, in a few months, that will be fully unsupported, but for the sake of today, it makes for a good demo environment there. So I'm going to open up Internet Explorer. We've got IIS installed, we've got a starter page, and we've got this little job site starter kit. So this application is a 2-tier ASP.NET application. It's back in the .NET 2.0 family. It's quite old, and it's a 2-tier app. So it's talking to MS SQL Server in the back end. And so this app is here. Essentially, users can go in and post resumes, search jobs, get information, and it's pulling it in out of SQL Server. If I open up iNet Manager, we get some information here. So I've got both sites are here, a little default site, my little job site. If I go to application pools, we can see I've got a couple of app pools here, both the default one and our jobs app pool. You'll notice that from an identity perspective, we're actually utilizing an Active Directory service account, this jobs-svc, to run that application. So the app uses integrated Windows Auth, so it can automatically talk to a database utilizing this credential right here, this service account. And so this is running right here on this virtual machine. When it came time to containerize this application, as I mentioned, I could certainly come down, fire up Notepad, start kind of setting up from statements and run statements and building my own Dockerfile. But if I'm new to the container world, if I'm just now kind of learning Dockerfiles, this can be pretty intense and can be pretty intimidating. So one of the options that we have is to use that conversion tool for us instead. So what I'm going to do here is I'm going to fire up PowerShell, run that as an admin, and let me just switch over to my DAC directory. Good, so I've got this little DAC.exe file. So I can run this. DAC is distributed as a command line tool, and so it's really focused here on this server. I've just popped the binary onto the machine, and now I can use that on this server to do this discovery process. So what I can do is I say DAC, or let me get rid of that. So I'll say DAC, we'll say discover, I'll give it a file system, and we'll say the C drive there. And so DAC's going to come back and say, hey, we've got 2 different modes. What would you like to do, standard or lift? And so the way DAC is set up is that typically with containers, we like to have 1 application to 1 container, a 1-to-1 mapping there. If there were 20 applications sitting on this IIS box, what the standard mode would do was go generate 20 different apps, 20 different Docker files, 20 different sets of app code. The alternative here is what we have is what we call lift. And so lift are for applications that if we had 4 or 5 applications that were tightly wound together, it was going to be really hard to pry them apart or separate them. The lift would pick up all 5 of those apps and jam them into 1 Docker file, so more of a monolithic container there. Certainly an option for older apps that it's going to be harder to separate. We can just grab everything on the server and put it into that environment. So if I hit 1, we can see we've gone off and done a whole bunch of stuff. If I come back up, we can start at the top here. So we've discovered the operating system. So we're looking at the OS, we're looking at what features and roles are installed in that environment. What can we glean from that OS level? Second, we come down and start looking at the different detectors that we have installed. So by default, we run all of them. That's Tomcat, IIS, WebSphere, WebLogic. These are the ones we're going to use. When we come down, we didn't find any Tomcat applications, but we did find some IIS applications. We got 2 apps that have been discovered there. So at the end, we get a very brief little summary, little report that says, hey, we found 2 different apps. We found our default website and we found jobs. What do we want to do here? Do you want to go ahead and containerize these or just leave it be? And I'm going to say, yes, actually, I would like to containerize them. I'll say all. And now then we've taken the application code, we've taken the Docker files, and we wrote them down into my user directory. So I'll open this up. We've got a default website and my job site. Under jobs, we've got a Docker file. We've got information from IIS. We actually have all of our app code here. All of our ASPX pages are right here. And we're ready to go from a containerization perspective. So to actually do the Docker build here and actually show what we have, I'm going to flip over to a Windows Server 2019 virtual machine because we actually need Docker installed to do that Docker build. Can't do a Docker build on an 08 server. So I'm going to flip over here. This is again Server 2019 so we can start looking through this Docker file. And so we've got a from statement. We set the shell to PowerShell. And we're starting with this ASP.NET image that came straight from Microsoft off of the Microsoft Container Registry. So we'll start with ASP.NET. We removed the website that was there by default in that container. We installed some operating system level features around IIS and additional settings that we detected. The application had a port binding to port 8080, so we brought that over. We don't kind of guess or stick everything on 80. We maintain that because when DAC talked to IIS, it figured out, hey, this app's on port 8080, excuse me, so we'll bring that over. Next, we create our app pools, copy files, and then set up the website. So pretty straightforward kind of process that's going to look like a whole bunch of other IIS-based images, but the user didn't have to author this. DAC really turns your folks, instead of Dockerfile authors, more to Dockerfile editors, where we can edit this, we can tweak things. If I need to adjust that from statement over to a base image of 2016 instead of 2019, I can swap those in and out, and then make any additional features or additional kind of capabilities that I need to add into that file. So good, so that's the file that's been added right there. If I switch over to a couple PowerShell snippets, what I can do here, I'll set up some environment variables just to name this, and I can build the container. So let me say run. We went and built that container. At this point, then I can run that container. I'm going to run it, calling it jobs, publishing a port, giving it that image. What we'll find here shortly is that we've now in my developer machine up and running with that application. So there's a problem here. So when we took that application, we took the app, but that application was utilizing a service account, if you'll remember, that talked to Active Directory. And so by default, if we just take the app, we're getting an error here saying, hey, we can't talk to the database with this default account here. We don't know this container doesn't know anything about AD. We do not domain join containers. So how can we enable that? And so what I'm going to do is not get too deep into it today, but I'm going to recreate that container and give it a particular option, what we call a group managed service account. This is a special credential that allows us to take a container and talk to Active Directory. So if I rerun the container and provide it with that identity, then when that container starts up, it's not going to use the default identity in the container. Instead, it's going to go out and use an Active Directory ID and then not format very pretty for me until I refresh it to make that that request against the database and hook up all the integrated windows auth. So I'll give this just a moment, and boom, there we go. So we've got an application here that's running. This is a 15-year-old application, was running Windows Server 2008. We went out and used the Docker application converter against the VM, pulled out all the code that we could, generated a Dockerfile, and now at this point, we have the exact same app running on a virtual machine, and now ready to be pushed into Docker Trusted Registry. So this has been containerized. And oh, by the way, no code changes, 0 code changes for that application. So that's kind of one example of how we can use Docker Application Converter. And so will this work flawlessly and perfectly for every application out there? Probably not, but it's at least going to give you a strong starting point and make it easier for you to go out and utilize containers with some of these older applications. So that's Docker Application Converter and how we can, again, kind of expedite that process. So, yes, question? Yeah, so the question is, if I'm on Linux, it's the same process? Same process. So instead of an exe file, it's just a binary. The tool's actually built in Golang, so it's cross-platform. And so we simply compile it for Linux, we compile it for Windows. We've got a 32-bit version and a 64-bit version if you need it for an older operating system. So again, my flavors are a little more Windowsy today. The exact same thing would be as if I had a legacy Java application. It would do the exact same introspection for WebLogic, for WebSphere, et cetera. Yes, sir. Right, so the question is more information around the AD configuration. So there is a process that we basically have to map the old service accounts to group managed service accounts today. Today the tool is not detecting that. We're looking at how we can have the tool automatically detect these service accounts and at minimum kind of generate a report of what you need to do when you go talk to your identity team, your Active Directory team or wherever. But today I manually created an account and then wired up the GMSA. That's outside of the scope of the tool today, but we're looking at how we can use the tool to do identity type things as well. Yep, so there's lots of big plans for that tool, and it'll be getting better. Yes, question? Yes. Good. Question is around you're using .NET 2.0, what base image did you use? So the good part with .NET at least is that it's very backwards compatible in that it'll run on a lot of different stuff. The base image that I was using for that Dockerfile was the 472, just kind of the latest image that's there. And we just loaded that up and it worked there. There are times where sometimes you have to change your application pool to like a classic app pool. I'm not sure if we set that here. Actually, we did not. But that was able to run just fine on a 472 image. So good, I'll leave a little bit of time. I want to get through a couple more sections and we can do all the Q&A your heart's desire. Good, so we've got a containerized application. Sorry, what's that? Great point. Yes. So DAC is part of Docker Enterprise. So it's a piece that it's in the box. When you buy a Docker Enterprise license, you get access to DAC. Historically, we've used this as part of service engagements, where if we're doing kind of initial platform setups, if we're doing containerization, we use that as part of that. But it is part of the Docker Enterprise piece. Very good. All right. So now that we've got a containerized app, we need a place to run an application. And so there's typically kind of two main things that we're looking at kind of expediting and enabling from a Docker perspective. Excuse me. So the first piece is really what we call our day one operations. We want to go stand up a cluster. We don't have anything out there today. So we want to be able to stand up an environment. We want one that's going to be very fast and efficient, that's going to be very consistent. So if I stand up 3 environments, I want them to match and be identical. We want to be able to look at different infrastructure targets. So on premises, maybe have an AWS or Azure, and have a consistent experience across those environments. And want open APIs to allow our tooling to work easily. So kind of day one is I need to set up a proof of concept environment. I need to get going quickly. I want to use that on day one. Inversely, day two is all around after we initially set things up. How do I patch the containers that are running on here? How do I patch the underlying hosts? How do I scale up? How do I scale down to ensure I've got the right capacity for my applications? So that's all, and including things like disaster recovery. And so historically, this has been either a manual process. People were just kind of manually creating VMs and SSHing in and setting things up. It may have been something where you try to integrate with your existing tooling, but it wasn't easy to do, and it wasn't automated. And so there's ample room where you can misconfigure things, where things can go wrong, and can be a bit of a challenge. And so that's where with this latest release of Docker Enterprise, what we've been working on is how can we make that experience faster and better. And so for that, we've started putting in what we call our cluster lifecycle management capabilities directly into Docker Enterprise. And so this really falls down around three main pillars. The first being very detailed reference architectures. So we've long published reference architectures, very generic, what you need to get up and running with Docker Enterprise. It didn't assume any particular infrastructure provider. But if you talk to an AWS person, they want AWS iconography and specific service names, same with someone for VMware or for Azure. And so what we've done is had kind of infrastructure-specific reference architectures to say, hey, this is how you set up EE on VMware. This is how you do it on Azure, et cetera. And so that reference architecture gives very detailed guidance. Next is from an automation tooling perspective, trying to get away from folks manually creating infrastructure, manually doing configuration management. And so we have automated tooling baked in that will go out and provision all the infrastructure you desire. We'll do all the setup. We'll form things into a cluster. We'll install capabilities kind of on your behalf and automatically. So automation tooling is the second big piece here. And then finally, the third bucket here is around ecosystem integration. So common different third-party providers for monitoring or for logging or for storage drivers. How do I interface and integrate Docker Enterprise as a platform with one of those providers? And so we have a variety of what we call solution briefs that are write-ups, step by step, what you need to do to architect and then install Docker Enterprise with a lot of these common ecosystem partners. So that's one where instead of everyone having to go reinvent the wheel and figure things out for themselves, we're like, hey, let's standardize this, let's make it easier for folks to get going there. And so a lot of that's delivered on our Success Center at success.docker.com and can help if you're wanting to integrate with some of those common providers. So to show kind of what this looks like, I'm going to pop over here and start with a command line. And so everyone may be familiar with the Docker command, this Docker client. It allows us to do Docker run, Docker stop, Docker PS, all of our Docker commands that are there. One of the capabilities coming here with Docker in the 1903 engine and in the latest version of the platform is that this command line is now plugin swappable. We can add plugins into there. Docker can have first-party plugins. Other folks can develop third-party plugins. We can really expand this experience. And so in this command line now, we've got this command called cluster that's sitting right here. And so this is for managing Docker clusters. So what we can do is if I come in and say Docker cluster, you see we've got a variety of different commands here. So we can come in and we can create. That's going to spin up a cluster for us. It's going to create something new for us for that environment. And so that really helps with some of the day one pieces here is around being able to spin things up. And boom, I've got a cluster. I'm good to go for my proof of concept or my lab environment. That's good to go. But you see, we also have commands here around day two pieces. So if I want to take a backup of the cluster, I can back everything up and then be able to restore that when I need it. I can come in and I can do updates. So if I needed to update the runtime version of the engine, if I needed to update UCP or DTR or other platform components, we can make those changes and then run that update. And so we get to a point where I can see that I've got a particular cluster that's sitting up in AWS and some information on what we're running here, and we can go and then inspect that. So Docker cluster inspect AF4. We see all the information here that we've defined. And so what we've been moving towards is a YAML-based file that allows us to define exactly what we want for this cluster. And so to look at one of those files, what they look like, hopefully that is visible. We've got a YAML file called cluster.yaml, and this is where we define that cluster. Pretty straightforward. And so the different sections break down into a couple different ways. So first we have this provider section. The provider section is all about what I need to tell that infrastructure provider to get things up and running. So I can pass in a client ID and secret. I'm not doing that here because I was signed into the CLI, so we got some options. But I can say I want to be in AWS, I want to be in this region, add these metadata tags for my team or the project owner. I could put in, again, client ID or secret if I needed it. Any of the AWS specific bits go into provider. Similarly, this would be the same if this was Azure or VMware, which are the other two that we support today. Next, after the provider section is this cluster section. This is where we define Docker Enterprise platform-related pieces. So I can define, I want an engine, a specific version of that engine. I want UCP of a particular version, username and passwords. Anything that I put into the UCP configuration file, I can add into here, and then that'll find its way into the cluster for me. And if at any point, if I wanted to update this or change these, I can come in and change a version, then say Docker cluster update, and it'll take that and make that happen across the cluster, which is pretty fun. And then finally, we have this resource section down here at the bottom. And these are all about for that infrastructure provider, for the specific resources there, how do I want to configure and set those up? So here I've set up some pools of nodes, one pool for my managers, registry for DTR, then Linux workers and Windows workers in this hybrid type cluster. I can define the OS versions, I can define the quantities. If I want to scale this up or down, I can go from 2 to 12, say update, and we'll go set up 10 more nodes for that environment and add them to the cluster for us automatically. So we make it very simple to go and deploy clusters and be able to update those over time. So at that point, once we have that file, I can come in and say Docker cluster create. I can give it a file of cluster.yaml. And then the cluster will go out. It'll start connecting into that infrastructure provider and then spinning up resources for us. So we'll give this a moment to start. And in just a few minutes here, we'll start seeing in my AWS account, we will start seeing nodes popping up and running here momentarily. And so that'll give us the option to go and automate that entire process. I was trying to see how long it would take for those to show up. We can look at that here in a minute here. But we're up and running, and so that's going to go create all of the EC2 instances, the virtual machines for me. It's going to set up all the networking, all the storage, all the load balancers, all the pieces that I need to adhere to a best practice cluster that we've put out and documented here. So you can see already we've got nodes that are up and running. These will provision, and we'll be good to go here in 20 to 25 minutes. Not going to make us sit and wait for the entire time there. But want to see that at any point in the future, Docker cluster update, we'd be able to go and do that as well. This will be baked into the Docker Enterprise CLI, and again, it's one of those features that's out of the box to make it easier to go stand up infrastructures. As far as how this is put together, I would love to chat a little bit about kind of what's under the hood here. And that from a cluster management perspective, we started, as I mentioned, with those reference architectures, and with those solution briefs, those are written documents. At that point, we then take those and can fill out a cluster.yaml file. This is an infrastructure as code, a cluster as code file, if you will. We can check that into source control, we can version it, we can share it, we can make it much easier to replicate those clusters in different parts of the organization, all with a YAML file there. We get that YAML file to the CLI, and the CLI downloads a utility container that we call docker/cluster. That has Terraform and Ansible inside of it. So we've implemented this tooling directly into Terraform and Ansible. If you've seen the Docker Certified Infrastructure project over the past year, you may be familiar with this approach. What we heard back from a lot of folks is, hey, we like this Docker Certified Infrastructure thing, but it's kind of off to the side. We'd rather have it integrated. I don't necessarily have to want to go become a Terraform master just to go spin up a cluster. And so we've made it an even more kind of managed experience where you don't have to be deep into Terraform and Ansible. It's there under the hood, but we make it very easy for you with a YAML file to go define that. When that utility container goes out, talks to our infrastructure providers, I think it's AWS, Azure, VMware today. If you see one on there that is not there that you would love to see there, we have plans for more. We're waiting for feedback on what's the next platform we should really be focused on. So those platforms then will spin up virtual machines, we'll install Docker Enterprise Engine, UCP, DTR, everything we need for that environment to be up and running there in that infrastructure piece. So that is our cluster lifecycle management. We hope that this is going to be a way to make it much easier to stand up clusters for all your day one needs, but then on an ongoing basis when it comes time to patch, to update those runtimes, to update UCP, that we've got a way to do this in a more automated fashion that makes it easier to administer those clusters over the long-term for your containers. The last section I want to talk about briefly is around evolving the app. And so one of the things we've seen quite a bit on is once I containerize my application, I can do some other things around it. So historically, when we talk about applications, pretty straightforward. We have some users, they talk to the app does some stuff, some business logic, writes that to a database. Very straightforward. Once we have the centerpiece containerized, though, we can add containerized pieces around that to help augment and improve that experience. So instead of users talking directly to the app, I may want to stand up a reverse proxy, something like Nginx in front of it that can do some caching of content. Maybe I want to be more efficient with my resources, more SSL offloading, custom rewrites, any kinds of things that are pretty standard today for reverse proxies, but were really not that standard back in the day for that app when it was first created. So we can add a containerized app in front of that to do reverse proxy things. I also may not want to write directly to the database, so I may want to stand up a queue, something like NATS or RabbitMQ, some other kind of mechanism that I write into the queue, readers read off of that and write to the database. Relatively low-level effort to go and to update these kinds of applications and add these in. But what it does is give that application far better scalability and a more modern feature set without having to go completely burn the app down and rebuild it from scratch. So we get some benefits there. And then finally, if I deploy this into AWS or Azure, GCP, or a public cloud, many of those have managed database platforms, and it's an area that we have a lot of interest in, and a lot of folks want to move their database workloads. From an application perspective, that might just be a change of a connection string, and now we can go use that managed database, taking advantage of the price point, of the HA, the DR story for some of those databases. So, little pieces there. So just to wrap up a little bit today around tooling, first off, containerizing legacy apps have value. It allows you to take those applications, hundreds or thousands of apps that are currently you can't necessarily get rid of or retire yet. They're still being used. We can move those into containers and give you benefits there. Cost less to run, more secure, more portability. It's setting you up for the future. So there's value there inherently in modernizing these apps. And then next is that Docker is providing tooling, techniques, and strategies, anything we can to help make this process easier by investing into the platform. So both from a kind of a soft skill piece around different application archetypes and guidance, all the way into hard tools such as Docker certified, the Docker application converter, and our Docker cluster capabilities. We're trying to make this process easier and make it better for you that are moving those apps there. So if you're interested in being on the top of the list for all the latest and greatest bits that we've been talking about this week, make sure you check out the Enterprise 2.0 beta. And we also have Play with Docker, Play with Kubernetes. So with that, thank you all for coming today. Hope it's been an interesting look at how we're working with customers around legacy workloads, and hope you enjoy the rest of DockerCon. Thanks.
I think we have time for one or two questions, if anybody in the audience. Yes.
Thanks for giving the insights about how to convert the older products. Only one piece I have a question, particularly on that AD or identity access systems.
Okay.
How containers join with them for the authentication? Mm-hmm. Is there any mechanism we have it, or any methodology we have?
Yeah. So how the heck does this stuff work with identity, like such as Active Directory? So in jointly developing Windows containers with Microsoft, the pattern that Microsoft has put forward is that, hey, we can't domain join every single container. Active Directory was made to have a computer join and it sits there for 10 years and we never touch it again. Not the join the domain, leave the domain, join the domain, leave the domain. Like the container lifecycle just doesn't work well with Active Directory. So the approach that they use is there's a capability in Active Directory called Group Managed Service Accounts, GMSA. It's an Active Directory thing. It's not a Docker thing. It's been over in AD for years. And it's essentially a passwordless service account. We don't have a username and password. So you don't have to log in every 180 days and reset things or do any of that. So the pattern that Microsoft does is that we don't domain join the container, but we domain join the host machines that we're running on top of. So if we have 10 Windows Server VMs that are running our containers, we add those to a group and we domain join those. Then when I create a GMSA over in Active Directory, you talk to your AD team, when they create that credential, they whitelist which nodes that service account can use. And so we say, create this account, and oh, by the way, these 10 VMs, they're cool, they're good to use that. And then from that point, when I create a container, I can pass in a reference to that GMSA, and the container at start time has some code in it that says, normally I default to just local system as my identity, but if I have a GMSA, it goes, oh, actually, I need to be service account A, GMSA A. So then when those requests leave the container, it uses that identity to talk to network file shares, to talk to SQL Server, to talk to MSMQ. Anything that's domain secured, we can do that. And so it's an implementation pattern, but the main kind of takeaway I hope we got here is that oftentimes there's no code change to use integrated Windows auth. We have to go set up a service account, but we're not having to recompile binaries. I didn't have to break open source code. We didn't have any source code. And so we were able to use that to move that application without having to make material changes. It gets really expensive and time consuming if I stand up here and say, hey, for all 500 of your apps, we've got to go spend 3 weeks a pop re-engineering it. We really try to minimize that if at all possible, and this is one of those patterns to do that.
Wonderful. Thanks a lot.
Thank you. Good question.
Anybody else? Yes.
Yep.
It's our last one.
Sure. I like your hat.
So you demonstrated kind of adding things, or basically, here, we're going to lift and shift this over. Do you have any examples of actually migrating newer infrastructure around that? Like, have you actually put people in Kubernetes plus, say, Istio whilst they're still running a 10-year-old ASPX app? Like, have you been able to bridge those gaps yet?
So I'm bridging gap. So until about 3 weeks ago, all of our Windows stuff was all in Swarm, and we're just now getting kind of up to 1.14 with Kubernetes is enabling that. I'd say in general, like in the Docker Enterprise platform, our layer 7 load balancer with interlock, we're able to do kind of modern routing into those apps that are running in a container. We've got storage, we've got identity. I have not done anything with Istio yet on how to implement those pieces there, but I would assume the process, once you're containerized, there's kind of a contract of how those containers work and how data gets in and out and how we implement. I would suspect that integration with something like Istio would be pretty straightforward once you're in a container. That's a good question. Kind of early yet to have really touched all that myself. So that'd be interesting to see. So good.
Awesome. Thank you.
Thank you all. Enjoy DockerCon.